Hello and welcome to Quadratics 2.3, Graph to Symbolic. Okay, today's lesson we're gonna write symbolic form of a quadratic function. And the symbolic form that we're gonna write in particular is right here in the middle. Yeah. And if you look at the form or the contents or the way it's written rather, you're gonna hopefully recognize that this is called intercept form. Okay, so we're going to gather information from either things that they tell us in a written paragraph, or that we're going to gather information from what they give us in a graph. And the information that they give us is going to help us put together the symbolic form of this quadratic. Okay, so I think I'll be doing maybe 4 examples. I think it's three examples, and hopefully you can use that as a guide to get you through your homework tonight. Okay, but the basic premise is you're going to get information either from information they give us written in a paragraph, or we're going to get information from looking at a graph, and the information we gather from those two sources are going to help us put together the equation. Okay, so that's going to be our overall steps that you can follow along with as far as our goal. Okay. All right, so here we go. So this problem is not going to be written in a paragraph where it gives us all the information in a paragraph. It's going to be given to us in the form of a graph. And if we can get hold of information like the x-intercepts, the y-intercept, and the vertex, then we can proceed with getting our equation. Yeah. Do we need to have all three of these things? No. Yeah. The y-intercept and the vertex, they're not deal breakers. If we don't get them both, yeah, and we only get one of them, then that's fine. Yeah. And if there are certain problems where we don't even have the y-intercept or the vertex, and we have another bit of information, that's fine also. Yeah. So the y-intercept and the vertex, those are not deal breakers as far as being able to achieve success and getting our symbolic form. Okay. But the one piece of information that kind of almost is a deal breaker, that if we don't get it, then it's going to make our life very difficult to actually eventually get the final answer, is the x-intercept. So we actually kind of want to have that. Yeah. Okay. It's not a deal breaker if we don't get the x-intercepts, but it makes our life way easier if we actually have them. Okay. So let's go for it. Let's just get those three things, and let's see how they actually work together to get our final answer. Okay, so x-intercepts, let's look at our graph. What are the coordinates for my x-intercepts? And hopefully you say -1, 0 and -3, 0. All right, so, and when we look at these coordinates, yeah, I'm going to say a couple of phrases where you're going to say, wow, where did I hear that before? And the basic reason why it's going to sound familiar is because in other lessons that we've already done, I've said those exact same phrases where, yeah, we're able to get a hold of the x-intercept because we have equations that lead us to those coordinates. Okay, but this time we're going backwards. Normally the route we go is we're given the symbolic form already, and from there we get the location of x-intercept. So we're going in the complete opposite direction. Okay, but as far as going in a complete opposite direction, you're gonna hear the same phrases that we use to actually get the coordinates in the first place. All right, so the thing that we do know is the shape and form of our final answer, which is going to be looking something like this, where we have a letter in the front. Yeah, I mean, well, it's a letter right now, but it's going to turn into a number later on. Then we have 2 blank parentheses. Actually, you're not going to remain blank for long, because we know that in symbolic form, yeah, for a quadratic, especially in this intercept form, like this form, we have an x in the front right here. Yeah, and it's going to be x plus or minus some kind of a number here, and plus or minus some kind of a number there. Okay, so back when we actually had possession of the function, the equation, the intercept form, yeah, I always asked you this question. I would always ask you a question that sounds just like this. What number can I put in place of x so that when it interacts with the number right here in the blank spot, it creates a 0? Yeah, and that was kind of like solving for x. That was a couple lessons back also. Yeah, where we set x equal to 0 and we figure out what number for x cancels out the number that's sitting in this blank spot, and it makes a 0. Okay, except this time we already actually have the number that's going to cancel it out, right? Because if you look at this ordered pair, -1 sits in the spot for x, 0 sits in the spot for y, yeah, and x we know it as input, 0 or the y value we know that as output. Yeah, so if we think of it this way, I'm plugging in -1. right? Because that's my input. I'm going to plug in -1 in place of my x. Yeah, so it's going to be -1 basically right here. Then it's going to add or subtract to some kind of a number. And when the -1 plus or minus the number that we don't know yet, but we're going to figure it out very soon, when those two numbers interact, they're going to make a 0. Okay? And that's how we're going to unlock the secret to figuring out what's the number in this blank spot, right? So it's going to be -1 plus or minus some kind of a number equals 0. So what's the only number that can possibly fit in this blank? So -1 plus or minus some kind of a number equals 0. What's the number that can work? And hopefully you are all saying +1, right? Because -1, when I plug it in for x, -1 plus 1 makes 0. Okay, and that's why it's so important to know the role of each placement in an ordered pair, where -1 is your input, 0 is your output. So that when I come to these situations where I have to figure out how this can, I guess, go backwards and lead us to the equation, right? Then it all makes sense, right? Plug in -1, add 1, you get 0. Okay, so let's go for the second parentheses. We're going to plug in -3. Then we're going to add or subtract some kind of a number, and it's going to produce a 0. So -3 plus or minus a number makes 0. So what's the only number that can fit in this blank spot for -3, right? -3 goes in place of the x, plus or minus a number equals 0. What's the only number that can work? And hopefully you say +3. And if you did, good job. Right? -3 plus 3 is 0. Yeah, so that's why, remember I said earlier, yeah, if you need to get a hold of certain coordinates, you need to get the x-intercepts, right? Because we're trying to create what is called intercept form. Yeah, and when we refer to this as intercept form, we call it intercept form because this form is actually really good at getting the x-intercept location. Yeah. So if you want to create intercept form, yeah, we gotta have the intercepts, right? If we don't have it, I mean, it's like I said, it's not a deal breaker, but it's gonna make our life way more difficult to get a hold of the answer. Yeah, we're gonna have to find a lot more information. Okay. All right. So to be overall fully done with this problem, we need to get a hold of the a value. Yeah. Once we get a hold of that number that goes in place of a, we're done. Okay. And remember how I said earlier in this problem, we don't need to get both the y-intercept and the vertex. If we have them both, that's nice. Then we have options. If we don't have them both, that's not a deal breaker. Yeah. And we could even actually get this problem still solved even if we had none of them. Okay. But because some problems actually are going to be what we consider nice, because when you look at the graph, it's going to actually be at a nice set of coordinates, then yeah, you want to have those options, right? Where you're flexible, where if you have them, good, use them. If you don't have them, that's fine. You don't have to use them. You can use other sources of information. Okay, so let's see if we can actually find the location of the y-intercept. And if we look at the graph, we can see that it's at a location of 0, -6. Okay, and the vertex. Does it look like we have the vertex? Yeah, it looks like we have the vertex. And it looks like it's at -2, 2. Okay, so just like in the previous problem, or in the previous, not problem, but because this is the first problem, just like in the previous part of the problem, right, we're going to use the ordered pair to help us figure out numbers, yeah, or parts of this equation. Okay, so just think of it this way, right? 0 is my x, -6 is my y. -2 is my x, 2 is my y. Okay, and just think of the role of the x. The x is the number that I'm going to plug in. So let me ask you a question. Yeah, in general, would you rather plug in a 0 or a -2? Because we're trying to evaluate which number is actually the easier number to work with. Which piece of information is easier to work with, the y-intercept for this problem or the vertex for this problem? Now, each problem is going to be different. I'm just saying for this problem, if I had a choice, which we do, of which set of coordinates we want to use, y-intercept or vertex, which one has the potential easier route to get to our destination? Plugging in 0 versus plugging in -2. Which one do you think is going to be the easier journey? And everybody has their own preferences, right? But in general, I believe that most students are going to say, duh, plugging in 0, because if you plug in a 0, then things just disappear, right? Yeah, that's true. If I plug in -2, things are not going to disappear potentially, and the numbers are going to start getting kind of ugly because it's a -2, right? So yeah, if we had a choice, let's use the y-intercept because I get to plug in a 0. Okay, so 0 is going to go in place of my x. So there's an X there and an X there. So I'm going to put zeros in both of those spots. So let's start doing that. So we got 0 plus 1, and we have 0 plus 3. Okay, we don't know the A, that's what we're trying to go after. Then we have the equal sign right in front of that. And then we have the letters f of x. And you're saying, I plugged the 0 for x, and negative 6 belongs to the spot that is corresponding with y. Okay, so the thing you got to realize about f of x is f of x and y are interchangeable. They basically mean the same thing. I mean, well, yeah, I guess they're pretty much the same thing. Okay, I hope I spelled interchangeable correctly. Okay, they're basically interchangeable. So if I wanted to write f of x in front of that equal sign, I could. If I wanted to write the letter y in front of that equal sign, I could also. Okay, but for the purposes of this problem, we're going to call it a y, because then that's going to fit with the story a little bit better, where 0 took the place of all the x's, and negative 6 is going to take the place of the y. Okay, so just keep in mind, yeah, f of x and y are interchangeable. Okay, so I'm going to erase this y, and I'm going to put a negative 6 in that spot instead. Okay, so now do you only see one letter left in the entire problem? Yeah, all we see is the letter A left, and by using algebra, we can actually solve for A, and when I solve for A, I get the missing number that's going to go in that spot. Okay, so let's do this. We got negative 6 equals A times 1, because 0 plus 1 is 1, and times 3, because 0 plus 3 is 3. Yeah, isn't it good that we plugged in 0, right? Because our numbers that we added to or subtracted to or whatever it's going to be in the future, they don't change, right? 0 plus 1 is 1, 0 plus 3 is 3. Yeah. If I plugged in negative 2, yeah, I can still get the answers pretty easily, but it's going to take a lot more thinking. Okay, so let's just continue on. We got negative 6 on the left side. We got A times 1 times 3. So A times 1 times 3, hopefully you say is 3A. Okay, and then when I solve for A, you want to get the A by itself, so you divide both sides by 3. And when I do that, I get A equals negative 2. Okay, so I go way back up to that line that holds my answer for my symbolic form. I'm going to erase the A because I just found what A is. We found that A is negative 2, so I'm going to drop a negative 2 right in front of that first set of parentheses, and we're done. Okay, so if I actually had used negative 2, 2 for my coordinate, would it still have worked? Yeah, of course it would still have worked. I will get the exact same answer. My journey would just be a little bit different. Okay, so let's move on. Problem number 2. Okay, so we have the same exact puzzle that we're going to solve, right? It's not the same graph though, but it's the exact same set of steps. So I can start actually just writing stuff out on this set of lines, these blank lines right off the bat. Without even looking at the graph, I can already start doing this. Yeah, because every problem is going to have basically this kind of starting point. Yeah, I haven't even looked at the graph yet, and I'm writing all this stuff down already. Okay, so when you start getting an understanding of I guess, what you can take for granted as far as a starting point, you have a lot of information already without even looking at the problem. This can all be written without even taking one glance at the problem, one glance at the graph yet. Okay, so let's look at the graph and let's see what it tells us. So x-intercepts, well, it looks like we have one at negative 1, and we have another x-intercept at 3, so I can put that in already. Okay, and before I even go down to the y-intercept and vertex, I'm just going to start filling up the parentheses in my symbolic form. Yeah, so just do the reverse thinking again, where you say to yourself, negative 1 is going to get put in place of x. So it's going to be negative 1 right here in place of x. So negative 1 plus or minus some kind of a number equals 0. So it's the only number that's going to make that story true. Negative 1 plus or minus some kind of a number equals 0. And when you give it some thought, you're going to hopefully say positive 1 makes that happen, right? Negative 1 plus 1 is 0. Okay? And this is the kind of stuff that you know what I told you a couple lessons ago where I said I'd take away the calculator because I want you guys to be able to use your brain to think? Yeah? This is one of the tasks that I kind of want your brain to be able to do, where if I want your brain to figure stuff out in its head, yeah, on its own, without necessarily writing it down, without using some kind of a tool to map it all out, right? Just use your brain to just work things out. Yeah, to see the sequence of steps, the logic that's going to happen. Yeah, that's what I call exercising your brain so that it's more functionable. Yeah, that's the kind of practicality I want your brain to have, rather than, ooh, look, I see 2 times 3. Ooh, I think I need a calculator for that calculation. Okay, because I have a lot of kids that have come through my classes or my doors and been in that exact same frame of mind where, yeah, they see 2 times 3, they go straight to the calculator, and that is not good. Okay, so let's figure out this second parentheses. We're plugging in 3, and when I plug in 3, it becomes a 0. Okay, so let's logic that out. So put a 3 right here in place of x. So it's going to be 3 plus or minus some kind of a number makes 0. So what's the only number that can make that story true? 3 plus or minus some kind of a number makes 0. And hopefully you all say negative 3 makes it happen. Okay? All right, so the next piece of the puzzle is the A. Okay, so hopefully you're starting to get the sequence where the x-intercepts, they get you what part of your symbolic form. Yeah, the x-intercepts, they help you get the parentheses. Yeah, the x-intercepts, they kind of indirectly help you get the A, but not right off the bat, right? The x-intercepts right off the bat, right from the very start, yeah, gets you the parentheses. The other 2 pieces of information, the y-intercept, the vertex, they get you the A value. Okay, so you got to try to understand this as the pieces of information in this list, they all play a part in accomplishing our goal. Okay, and if they all work together really well, the goal can be realized. Okay, so x-intercepts, their role is get the parentheses. Y-intercept or vertex, their role is get the A value. Okay, so let's see, the y-intercept, yeah, I think that's a pretty nice coordinate. Okay, so don't always trust the graph when you see it, because sometimes the line can look like it's exactly at 0, negative 3. So we're going to trust it this time, but in the future I'm going to try to trick you guys, yeah, where I'm going to make lines, and unless I have the dot like how it's written on the graph like that in the picture, unless I have the dot actually at that spot, don't trust that just because it looks like it's at 0, negative 3, then it is at 0, negative 3. Because I'm gonna play some games too, yeah, where I'm gonna make it look pretty good, and you're gonna be tempted to use it, but because the dot's not there, then don't use it. Okay, so just keep that in mind. Yeah, if I plan out my assessments really well, I have the dots there for you because I'm gonna force you to go on a route that I want you to go on. Yeah, so that you can prove to me that you can do it no matter what piece of information I give you. Okay, so vertex is the one that actually has a dot, and that is at 1, negative 4. So because I didn't give you a dot for the y-intercept, but I mean, I just put it in the list anyway, yeah, I'm going to force you to use the vertex to get this A value instead. So last problem we used the y-intercept to get the A value, yeah, this time I'm going to force you guys to use the vertex, okay, just so that you can see what the other journey is like, where you cannot plug in a 0, you got to plug in a regular number like 1 for x and negative 4 for the y value, right, and see what kind of journey that takes you on, because plugging in 0 is always the easiest route, because zeros, like I said, right, they don't really change anything. Okay, they either don't make things different, or they make things become 0 because you're multiplying by it. Okay, so yeah, I want you to go on the route that we're going to use the vertex. So remember I said f of x is interchangeable with which part of this ordered pair for the vertex? F of x is interchangeable with y. Okay, so let's start plugging in the information we know. So we know that we have 1 plus 1, right? And you're thinking, well, where did you get the 1 plus 1 from? Well, the plus 1, we know where that is from. That's from our line right up above. Okay, the one that's in the front, that's my x value that we plugged 1 in for, because we're using the vertex to get this answer. So we're plugging 1 in place of x. Okay, so my other parentheses is going to be 1 minus 3, because I'm plugging in 1 for the x value also. And then since f of x and y are interchangeable, I'm going to put a negative 4 right in front. Okay, so notice how we don't have 0 plus 1 and 0 minus 3 like the previous slide. So I mean, the math is not going to be that much harder, but for some kids, when they start seeing numbers like positives and negatives that have to be combined, yeah, that's where the temptation to use the calculator comes in. And for my kids, sorry, you can't use the calculator, so too bad, so sad. And oh, I forgot to write something, and I forgot to write the A value. Sorry about that. Okay, all right, so we have negative 4 equals A times 2 times negative 2. And hopefully you guys can get the right hand side of the equal sign and realize that it's negative 4a. Yeah. And to get the a value by itself, we're going to divide by -4. And we're going to get a equals 1. So we're going to go up here. We're going to erase the a value. And we're going to put in that spot a1. And there you go. Okay. So now you just saw the journey of how to get the answer using the vertex. So first problem we did, get to the journey, or go through the journey with the y-intercept. Second problem was get to the exact same destination, right? When we do a different number, obviously, right? But same result, we got the symbolic form using the vertex. And in this last problem, we're going to get there by not even using the y-intercept and the vertex. So you're probably thinking, why do you even have y-intercept and vertex in the list if we're not even going to use it? Well, yeah, to keep things consistent, I like to make the look the same. Yeah, where just because we don't have access to information doesn't mean we can't eventually get it. Doesn't mean that we don't actually need it, right? It's still important to have these things, because in the future, when we start doing other things, getting this entire list of information, yeah, via the routes that I'm going to show you is going to be kind of important. So yeah, we might not even actually end up using the y-intercept and the vertex, but I'm still going to make you find it, yeah, just because it's going to be a good skill to have for future problems. Okay, so let's read through this problem, because this is not a graph, so they're going to give us information via written expression. Okay, so find a symbolic representation for the quadratic function with zeros at x equals 1 and x equals -3. Okay, so this is the first time I think you've seen this phrase, with zeros at -1 and, I'm sorry, zeros at x equals 1 and x equals -3. So what does that phrase zeros at x equals 1 and x equals -3 mean? Well, it's basically what an ordered pair basically says to you, where if I plug in 1, my output, my answer will be 0. So when they refer to something as a 0, it pretty much means, yeah, that 1 is the number that when I plug it in, it has an answer of 0. Okay, so that's kind of like what the phrase zeros at x equals blank and x equals blank, for whatever numbers they tell you in the future. It's basically telling you that when I plug in those numbers, I'm going to get 0 as an answer. Okay, so when you hear that phrase, you're going to just say to yourself this. Actually, you know what? Just like in the previous problem, watch what I'm going to do right off the bat on this set of lines. Yeah, and I should have actually just done this right from the beginning before I even actually read the problem, because, like I said, right, I don't even need to read the problem to get all this information on the paper already, right? Because all this is pretty much set in stone, right? This is stuff we can actually know and take for granted. Okay. So because we know we have zeros at x equals 1 and x equals -3, what should I do to find my x-intercepts? Look at the numbers I just dropped right in those parentheses, right? Because the problem told me straight up, I got zeros at these two x values. So they're telling me that if I plug in 1, I'll get a 0. If I plug in -3, I'll get a 0. And that's what I said is the basic definition of the ordered pair for an x-intercept, where if I plug in 1, I get 0. If I plug in -3, I get 0. So they're just writing it in a really, really different way. Yeah, so you're probably saying, well, why don't they just write it how you just said it? Yeah, and I go, yeah, they actually could do it if they wanted to. Yeah, but they rather have it like this. Okay, because this is how math people phrase their information. Yeah, they phrase it in this way. And yeah, they could be straight up and just tell us that yeah, if I plug in 1, I'll get 0. If I plug in -3, I'll get 0. But where's the fun in that, right? And this is where you're going, oh no, math is not fun. What are you talking about? Okay, so because we have those two coordinates, can we reverse engineer it to get the contents of the parentheses? Yeah, of course we can, right? Because like I said earlier in the previous two problems, we're going to plug in 1 in place of x, and it's going to add or subtract to some kind of a number, and we're going to get 0. Yeah, so 1 plus or minus what number makes 0? So what do you think is going to unlock that puzzle? What's going to be the missing piece that we need to put right there, where it's going to be 1 plus or minus a number makes 0? And hopefully you say -1. Okay, and same goes for the second parentheses. -3 plus or minus a number makes 0. So what is the number that fits inside this blank? And hopefully you say +3. Okay, all right, so as far as the next two lines, the y-intercept and the vertex, we cannot get this from this paragraph. Yeah, they do not tell us at all what the coordinate for the y-intercept and the vertex is. Did I say x-intercept earlier when I was talking? Maybe I did. Yeah, sorry about that. But as far as the next two lines of information, y-intercept and vertex, we cannot get it from the paragraph. There's no way we can get that with the information given. Yeah. The only thing that they actually did give us is they gave us a point that the graph goes through. So it says this graph that we don't see, yeah, it's going to pass through 7, negative 20. So I'm just going to label this coordinate PT, pass through 7, negative 20. Okay, so you got to remember, this is a coordinate. All coordinates tell us the exact same information in this way, where if I plug in the x value, we're going to get the y value as an answer. Okay, so if I plug in 7 and I do all the calculations like adding, subtracting, multiplying, dividing, whatever it is, right? I plug in 7, it's going to eventually get an answer of negative 20. Okay, so think of 7 as my x and my negative 20 as my y. And that should actually make the light bulb go off in your head. Ooh, wow, 7 is x, negative 20 is my y value. Isn't that kind of like what we did when we worked with the the y-intercept and the vertex? Didn't we plug in the values for the y-intercept and the vertex to get our a value in the previous two problems? And hopefully you're all shaking your heads at home. Yeah, you're saying, oh yeah, I remember that. You just did in the previous two problems. So let's do that for this one to get our a value so that we can get the symbolic form that's going to go on that top line. Okay, so let's write out what we have. So we don't have a, so I'm going to write a. And then in place of x, we're going to plug in 7. And then minus 1, and then 7 plus 3. Okay, and on the other side of that equal sign is f of x, which I told you earlier, f of x and who are interchangeable. And hopefully you say f of x and y are interchangeable. So we're going to put negative 20 in place of the y. Okay, and then let's just solve for a. So negative 20 equals a times 6 times 10. That's a big number. Okay, so we got negative 20 equals a times 60. Okay, so let's solve for a. Let's get rid of this 60. So divide both sides by 60. And we're going to have a fraction on the left side that's going to have to be simplified. You can't leave your answer as negative 20 over 60. You got to simplify fractions. So guarantee our fraction is going to be a negative because this negative does not have any other negative to cancel out with. So it's going to guarantee be a negative fraction at the end. Okay. And does 20 and 60 divide by a common number? Okay, think about it. Does 20 and 60 divide by a common number? And if they do, divide 20 and 60 by that common number. And what is that common number going to be? Well, they both divide by 20. So if I divide 20 by 20, you get 1. If I divide 60 by 20, you get 3. So my a value is negative 1/3. Okay, so I'm going to go back up to the top. I'm going to erase this a, and I'm going to put negative 1/3. Okay, and at this point, a lot of kids tell me, so we're done, yeah? We're done. We found the symbolic representation, so we're done. I'm like, yeah, your overall goal is done. You got your symbolic representation, but doesn't it also say state the coordinates of all all intercepts in the vertex? And you'd be like, darn, it does. But we don't have the y-intercept in the vertex, so guess what we have to do to get those values? Well, we kind of did this in a previous lesson also, yeah? Where when we had the equation, we were able to get the y-intercept in the vertex, yeah? So the work that you're about to see, you're going to be like, oh, okay, I've seen that in the previous couple of lessons. Yeah, I don't know which one exactly it was, but I know I saw this route that you're going to take us on right now. So I'll just leave it on the side right now. Okay, so we know the y-intercept has a 0 for the x value. So we're going to plug a 0 into our symbolic form that we just made. So, oops, I'm in eraser mode. So let's get back to pen mode. So the y-intercept, we're going to plug in 0. So let's do it. So negative 1/3. And 0 minus 1, and 0 plus 3. So this is negative 1/3 times negative 1 times 3. Okay, so negative 1/3 times negative 1 times 3. So the negative, right, the two negatives right here and here, they cancel each other out to make a positive. Then I'm just going to multiply all the top numbers and then all the bottom numbers. So 1's on the top. If I turn this guy into a fraction, he's 1 over 1. If I turn that guy into a fraction, he's 3 over 1. So 1, 1, 3 makes 3 on the top. And all my bottom numbers, 3 times 1 times 1 makes 3 on the bottom, right? Because if I just imagine that these are fractions, turn this guy into a fraction, that's 1 over 1. Turn that guy into a fraction, that's 3 over 1. So that's why I went 1 times 3 for my top, 3 times 1 for my bottom. And that eventually becomes a 1. Okay? Oops. How come that didn't erase? Okay. Alright, so my y-intercept is 0, 1. Okay, so now let's get my vertex. Vertex is going to take a little bit more work, so maybe I actually have to expand this little blank box that I have, because I think I need more space, because there's 2 things I have to get for the vertex. I got to get the x value and the y value. So let's start to go into there. Okay, so hopefully you remember that getting the vertex means that we're going to grab our x-intercepts and cut it in half to get the x value. So I'll start writing this out. Vertex, x value. And then you're going to say, oh yeah, I remember you writing it out this way when you did it in one of the previous lessons, right? So I grab my x-intercepts, 1 plus negative 3, cut it in half. So 1 plus negative 3 is negative 2. Divide by 2, I get negative 1. So I got my x value. Okay, and why is it so important to have that value? Well, like any other ordered pair, if I know my x value is negative 1, right? And x value meaning we plug it in. If I plug in negative 1, I can get the corresponding y value. That's why it's so important to get the x value, because when I plug them in, I can get the y value. Yeah, because I have the equation, I have the function that I can plug them into. So it's super important to actually get a hold of the x value first, because he unlocks all the secrets. Yeah. So let's do it. So negative 1/3, and then it's going to be negative 1 minus 1, and negative 1 plus 3. Okay, so I got negative 1/3 times negative 2 times 2. Is that all correct? Did I do my? Yep, it's good. Okay, so negative, negative right here, they cancel out. They make an overall positive answer. Okay, and then remember now, we're going to go, since this 1/3 is a fraction, we're going to go top times top times top. So that's going to be 1 times 2 times 2. Because these two 2's are on the top of the fraction, right? Because if I imagine 2 and 2 as a fraction, it would be 2 over 1, 2 over 1. Yeah, so 1 times 2 times 2 is 4 on the top. 3 times 1 times 1, right? Because 3 is on the bottom. 1's on the bottom, but it's negative 2, and 1's on the bottom of the 2. So 3 times 1 times 1 is 3. Okay, so I get positive 4/3, which is also known as positive 1 and 1/3 as a mixed number. Okay, so we're going to write 1 and 1/3 here, and that's fine. Okay, you could also write this coordinate also, negative 1 comma 4/3. Okay, we're not graphing this dot, so it's not necessary, you know, in my eyes, for me, it doesn't really matter if you write 1 and 1/3 or 4/3, yeah, for the y value. If we eventually have to plot this dot, yeah, you cannot leave it as 4/3, because how do you plot negative 1 comma 4/3 on a graph? Yeah, you would have to turn it into a mixed number. So in that situation, if you're graphing as one of your end results, then you got to leave it as 1 and 1/3. But since this is not going to be graphed, you can leave it as 4/3. That's fine. I'll accept that. Okay. All right. So problem 2 was probably the hardest, because not only did we have to find symbolic form, after we found symbolic form, we had to use it to find y-intercept and vertex. Okay. So be ready for anything that we throw at you. Yeah. And be aware that like I said earlier in a previous problem, yeah, the role of the x-intercept in this type of problem is to get the contents of the parentheses. The role of the y-intercept in the vertex, if available, helps you get the a value. But if we don't have access to y-intercept and vertex, we can use other sources of information to get the a value. Like in this problem, we used our passes through point, 7, negative 20. Okay, so it's not a deal breaker if we don't have the y-intercept and the vertex. It just makes our journey a little bit harder, because at the end we still got to have the y-intercept coordinate and the vertex coordinate. So we have to use our symbolic form to get those coordinates. Yeah. So I guess if you had to pick a type of problem that we're eventually going to give you, you're going to probably say, please don't give us the kind that has us use passes through points. Yeah, because we have way more work, and that's true. Okay, so I think you have 4 problems for homework tonight. Good luck. And if you have questions, feel free to ask anytime you need. All right, see you later. Bye-bye.